Hello, this video is going to cover deductive reasoning in geometry, if I can make that come in clear, to verify conjectures. Basically, we're just going to go over deductive reasoning and how to use that. And that's kind of the idea of this lesson. So let's look at the first thing. This isn't going to come through super clear, so I'm going to take it back off. Thought that would come through clear, but it is not. So let's do a definition of deductive reasoning. So, deductive. Okay, so deductive reasoning. That's just not coming through clear today, is it? All right, hold on. I gotta play with my camera. Ta-da! All right. Okay, so deductive reasoning. Maybe this will come through clear now. Huh. And it does. All right, so what deductive reasoning is the process of using logic to draw conclusions from facts, definitions, and properties. So we're looking at facts and different bits of information, and we're coming up with like a rule or a general thing that's true. So deductive reasoning uses facts to come up with something. Inductive, you used a pattern, like this is a pattern of something, and then I came up with overall a general thing. Another part of deductive reasoning that they use the wording for is the law of detachment. In deductive reasoning, if given facts are true and you apply the correct logic, then the conclusion must be true. The law of detachment is one valid form of deductive reasoning. So the law of detachment allows you to assume the conclusion part is true. Basically, it allows you to use your rules. Let's look at one other kind of idea. The law of, let me see if I can say this right. Sygalism, I don't know how to say that. But anyway, so the law tells us that if you have P and it applies Q, so P could be any kind of thing that you come up with, like, what was one of the examples I saw? If you're a penguin, then you must live and Q is like live in the southern hemisphere. So, and then you assume and Q applies R are true statements, then P applies R is a true statement. So it's basically saying, okay, if P goes to Q and Q goes to R, well then P has to go to R also. So that's kind of the logic through the law of, I don't know, Sygalism. I should know, but I don't think I've heard that word in many, many, many years. So let's look at a couple examples. So these are just from the bookwork. Let's see. So this first section at the top, like by one, just says, how does deductive and inductive reasoning differ from each other? Well, we just kind of explained that. Deductive takes facts and comes up with a conclusion. Inductive takes a pattern and comes up with a conclusion. Does each conclusion use inductive or deductive reasoning? So let's look at these two examples. At Bell High School, students must take biology before they take chemistry. Sam is in chemistry, so Marcia concludes that he has taken biology. So what kind of reasoning do you think that was? Did you have a pattern? Or was it facts that you then come up with a conclusion from? So that should have been facts that you came up with a conclusion, or deductive reasoning. A detective learns that his main suspect was out of town the day of the crime. He concludes that suspect is innocent. So were there facts or a pattern? So on that one, I also found it to be deductive reasoning. All right, so an example of inductive reasoning, I'm going to steal straight from your homework, so that's fine though. All the students in Henry's geometry class are juniors. Alexander takes geometry but has another teacher. Henry concludes that Alexander is also a junior. So that one is considered inductive reasoning. All the students in Henry's geometry class are juniors. So all of the students in his class are juniors. So then, but this one's in a different class. So it's kind of a pattern, right? That all the students in there are juniors. And then from that pattern of everyone being juniors, you can conclude that this other guy, Alexander, is also a junior. There really wasn't a fact. It's kind of a pattern that they are all juniors. Okay, let's look at a couple more questions up here. It says, determine if something is a valid by the law of detachment. Basically, did you follow it right? So let's look at 4. If you're given, if you want to go on a field trip, you must have a signed permission slip. Zola has a signed permission slip. Zola wants to go on the field trip is kind of what they came up with. So if she has a signed permission slip, can you assume that she wants to go on the field trip? No. You know that if you want to go on the field trip, you have to have a signed permission slip. It has nothing to do with if her wanting to go on the field trip. You just know she needs a permission slip if she wants to go. So that one, you didn't really use the given information. Let's look at 5. So that would be considered invalid. If the side lengths of a rectangle are 3 and 4, then its area is 12 square feet. A rectangle has the side lengths of 3 and 4. So the conjecture is the area of the rectangle is 12 square feet. Okay, can you conclude that from that information? Well, yes, you can. So it follows exactly what was given, and so you can conclude that. Kind of like the penguin thing I always talk about. It's in the book. It's one of the examples. If you're a penguin, you live in the southern hemisphere. So if you have a penguin, then you assume he lives in the southern hemisphere. So really, all you're doing for your homework is deciding if something's deductive and inductive, which is kind of challenging, but look through them and think about, is it a pattern? Is it a pattern of something, or is it facts? And then you decide if something's valid or invalid. And that's all you're doing for section 2-3.